Welcome everyone. So in this current session we are going to discuss about machine learning. Okay, so that is another part of our data science course. So just to recapitulate, we have already discussed about collection of data, and then we have done some exploratory data analysis on it, and then we have done some pre-processing. Okay, so once our data is almost ready, then we are going to run some machine learning model on our data, and our purpose is to generate some predictions and outcomes from the data we got. Okay, so first thing is we'll do the introduction to machine learning. So what is machine learning? So far in our traditional algorithms we have given some input, and then we have written some logic. So whenever we executed any program, so that program takes that input parameter, and then the based on the logic that we have supplied, it executes that code for that particular set of inputs, and finally it generates output. So the code logic always remains the same, and based on the different set of inputs the output varies. So that is how our traditional algorithms work, but that is different from machine learning algorithms. So here, instead of doing only whatever is written, but here the algorithms try to work like a human. So instead of only executing logic, it gains some experience from the data it is getting, and based on that it changes its behavior, so that the outcome becomes close to whatever should be the actual outcome. Okay, so initially what we do, we give some data set to the machine learning model, and from this data set it tries to understand that how the output variable is getting decided, means how this outcome or the target is closely related to the features we have supplied, and based on that it creates some logic on its own, so that when a next set of data is supplied to that model, then based on that experience it had from the previous data, it tries to generate the outcome. And if that outcome is very closely matching with the actual outcome, then we can say that the model training is quite good. But if there is a difference, if it is not actually matching, then what it does, the machine learning model, the algorithm, it again learns from the latest data set and it rectifies itself. Okay, so it is actually very much similar to human being. We learn initially something maybe in our childhood, and then gradually when we see new things and we have some experience, then we enhance our knowledge. So as we say that if we have some good amount of experience, then we work in a better way. So that is the only thing, that we whatever we learn, we don't stick to that like machines, right? So instead of that, what we do, we always gain some knowledge. We educate ourselves from the experience we get in our life. So machine learning algorithms or machine learning models are similar to that. It not only works as only the logic supplied, based on that it does not generate outcome. Instead of that, it always tries to learn from the data set, from the training data it gets, and gradually it improves itself. So that is how machine learning algorithms work. Okay, so generally matrix and vector notations of data are used for machine learning model feeding. Okay, so already we have discussed about this training data set, validation data and testing data. So now we will be able to find some more relationship with the models as we go on discussing. Okay, different types of machine learning models and how they work, what are the different algorithms available. That way we'll try to enhance our knowledge. Okay, so very common examples are that we see every day, like in our mailboxes we always have a spam folder or junk mail folder. So that is there is no one sitting and doing that, deciding that for ourselves, but they are some programs which are written and which are actually automatically executing every time any mail is coming. So based on some features it has learned that if this type of features are there, then it can be a spam mail. So whenever some mail comes to our inbox, then that program runs and it actually tries to just check that how many features are there with that mail and how they are closely related to the spam characteristic or non-spam characteristic, and based on that our mail that it's saved whether in our inbox or our spam folder. Okay, then we have this self-driving car, that is also a very hot topic now, that already there are few cars which are getting tested for self-driving. So it's like all the, you can understand if you have some experience of driving a car, that when you are driving a car, then there should be some initial training we should take, that how to run a car, what are the components, and how I have to, how I have to run them so that the car is working. But if you have driven any car, suppose in particularly in your location in the congested cities in different parts of India, then you will be able to understand that the initial training is not always sufficient, because you will learn a lot when you are actually driving the car in the road, right? So we always call that, okay, that person is an experienced driver. What does that mean? That not only the theory, but he or she has lot of practical knowledge about driving. So that is very important. So actually what is now being done, that with testing, it's important that all these types of experiences that the car should have, right? Because when we drive a car, then always the theoretical thing is not working, because sometimes we know that when we are driving the car, all of a sudden some people may come just in the middle of the road. So we predict those things from our experiences and we drive accordingly. So these are some important things that we human do every day, knowingly or unknowingly, and now the machines can also do it. So why this machine learning came into picture? Because the world is now data driven. So there are huge amount of data generated every day, and the data is like it's not only structured data, it is most of the time it is unstructured data. So all types of logs are getting generated, all types of feedbacks are getting generated. There are lot of social media data every day, every hour, every moment, lot of data is getting generated, and we are trying to get some insight from those data, right? So when so many huge data is getting generated, we have a lot of good hardware, good software are available, so that data is generated everywhere from each and every person in the world. So just people are thinking that if we can just use those data and we can improve the systems, not only on a traditional way, but doing beyond the capacity of a general machine and making it like human. So that's why I told you that it has something to do with artificial intelligence. So we are actually, what we are trying to do, that we are trying to teach the machine in such a way that it will have its own intelligence, and from experience it can improve itself continuously, so that we get better result every time. Okay, now how we are going to do the approach, then depending on how these algorithms work, what type of data set we feed to them, based on all this we divide machine learning broadly in 4 categories. supervised learning, unsupervised learning, semi-supervised learning, and deep learning. And there is another branch that is called reinforcement learning, and that is sometimes referred as one subsection of deep learning. So we'll come to that one by one. So the first type of machine learning that we are going to discuss is supervised learning. So it is kind of learning under supervision. So you can say it's kind of classroom training. The best example is classroom training, that every day students come to the classroom and the teacher teaches them, and teacher knows that what exactly the students should learn, and as per the plan every day the teacher is teaching the student, and student is also learning according to them. So that is the one example, very good example of supervised learning. So actually what happens in case of machine learning in supervised learning branch, that the models are trained with a set of samples having the desired output signal or the label or the target. So here I know that okay, these are the features and this is the outcome. So that entire data set is present with me. So when the model is being taught, then it has all the features, that is the input set, and it has the possible outcome, means the actual outcome as well. So that is the output set. So both the things are available to the supervised learning model when it is getting trained. Okay, models learn from these already known results and make adjustments in their inner parameters to adapt themselves to the input data. So it's like kind of that you have some questions and you have the answer also available with you. So what you are doing, that you first try to solve the questions and then you are matching with the answers, that whether your answer is correct with the actual answer. So if you get that okay, all the questions I could take correctly, I could answer correctly, so then I can be confident that okay, my learning is good, I have done the learning in the correct path. But suppose I got some questions and I gave some answer based on what I learned so far, and when I'm checking with the answer I'm seeing that no, it's not matching. So that does mean that whatever I have learned maybe in a incorrect way I have learned, so I have to change my learning. So supervised learning models also work in the same way. First it takes some training data with some output levels, then it learns accordingly, and then it takes some test data and it tries to generate some outcome based on the learning it has from the training data, and then it compares that predicted outcome with the actual outcome. And if it is matching, then we can say that okay, our models are working good. And if it is not matching, that means that maybe the model needs to rectify itself or needs to be trained properly with more set of data maybe. Okay, so supervised learning can be divided broadly in two divisions. One is called classification and another is called regression. So what is classification? Here basically we are working with some categorical data. Okay, so whenever we get some data, we divide them in multiple parts. So here you can see that I have some few circles and I have some plus signs, right? So these are the maybe two input parameters, x1 and x2, and these are the outputs generated. So what I have done, when I got this, I saw that these plus signs are mostly together and this red circles are mostly together. So I have put this line. So this dotted line means that now that output data set I have divided in two parts. So maybe this is the value I am giving, that okay, the outcome is y1, here the outcome is y2. So if the outcome falls in this region, then I am telling that okay, they are in the y1 class, and if the outcome is in this region, then I am telling that okay, the outcome is in y2 range. This is the y2 class. So I am just dividing the outcome in two types, two classes. Now this is a new data point that has come. So if the data point is here, that means that as it is in the left part of the dotted line, that means it is part of the y2 class. So based on my outcome data, I divide them in different parts, and when a new data comes, then I see that where it is in the based on the line, with respect to this line where it is. So if it is in the left part, then it is in the y2 class. If it is in the right side, then it is in the y1 class. That way I can do classification. So here it is a example of binary classification, means I have only two classes, but I can have multiple classes as well. Okay, so here I told you about email spam detection, so that you can say it is a binary classification. So either the email can be spam or not. So based on some characteristics, you can say that okay, if these characteristics are matching, then it is in the spam folder, and if it is in the right side of that line, then it is in the inbox folder. So that way this binary classification can be done. Okay, so these are the few applications we have mentioned of classification, that email spam detection, speech recognition, handwriting recognition, biometric identification, document classification, etc. And there are many algorithms available. Some of important of them are logistic regression, naive Bayes classifier, nearest neighbor, support vector machine, decision tree, random forest. Okay, so we will discuss some of them as we gradually move on in the course. Next one, in supervised learning, that is called regression. Regression is mainly applicable for continuous data. So you know, right, that there is a difference between categorical data and continuous data. So suppose categorical data means only few types, right? So few possible values are possible, but continuous data means suppose your marks in the exam, so it can be from 0 to 100, anything, right? So that's a continuous data. So based on other features of the student, suppose there are a lot of features of the students mentioned, and then the marks is mentioned. So I can, here for simplicity, there are two input features, and based on that I'm just plotting the outcomes. Okay, for some of the training data I'm just plotting that okay, if these are the two features, then where this outcome is plotted. So as it is plotted, then this straight line is drawn. Okay, these I will come to detail. For regression we'll discuss on some algorithms on regression. So this line, the purpose of this line is that it should be as close as possible to the actual outcomes. Okay, so this line is very important. We have to think of many situations, many aspects to draw this line. So once this line is drawn, then for a particular value of x and y, suppose this is the value of x and this is the value of y, so it merges here. So I can say that okay, when the value of x is there and y is there, this is the possible outcome, right? So that way I can generate the possible outcome for continuous data. Okay, so here we have a number of predictors, and a continuous response variable allows us to predict a continuous outcome. Okay, so the very common application that we will discuss about also, that is house price prediction. Means suppose what will be the price, what can be the price of a house. So you can understand that is a continuous data actually, but the house has some features. Suppose that what is the location of that house, how many storied, what is the quality of the flooring, what are the facilities available, etc., etc. So based on that we have to generate, suppose, the house price. So in that case what we can do, we can draw, if we can draw some regression line based on the training data we have, then whenever I have a new set of data, the testing data, then I can put them in that graph, and based on that line I have drawn, I can predict that what can be the possible price of a house. Okay, so few algorithms are available for regression. These are called the linear regression, non-linear regression, decision trees, Gaussian process regression model, SVM regression, etc. So we'll discuss some of them. So we have discussed about the overview of supervised learning and under machine learning, and there are two types, classification and regression. So understand that classification is mainly to handle that categorical data, and regression is there to handle continuous data. Okay, so we have completed supervised learning. In the next module we'll discuss about unsupervised learning. So thank you for now.